I want to thank all of you for coming to my presentation this afternoon on a science gateway for atomic, molecular, and optical science, democratizing AMOS research and education. I apologize for not being able to be present in person in Orlando, but I had some personal issues which required me to stay at home. Let me elaborate a bit on the phrase democratizing AMOS research and education. It is central to the work that we're trying to do to be able to take codes that have been developed in the atomic, molecular, and optical physics community, which are basically now being used by single groups, essentially the postdocs and the graduate students in those groups, and make them much more widely available to the general AMOS community. In addition, there are issues of education, which will be elaborated on as I go on with the presentation. I want to thank my accomplices who are listed in the slide. Without them, none of this would have occurred. As I said, the idea for this had been percolating in my mind for a long time, because I was wondered, why it was that these very able codes, very capable codes that were being used by essentially single groups in AMOS science were not more widely distributed and used in the community. And this, of course, is different than other areas of physics. For example, in say lattice gauge theory and gravitational physics, the codes that are used are distributed widely. So this all started initially with a workshop which was organized in ITAMP. About 40 people came to that workshop, and what emerged was to establish a portal where a subset of well-established and productive AMOS computer codes could be widely available and usable by the community on a web portal. We felt the codes needed to be well documented. Input and output should be fairly transparent, and one way to do that is by employing graphical user interfaces on the gateway. We initially wanted to strive for usability and interoperability among the codes of the organizers, and then longer term allow access to the AMOS community at large once we had a good feeling for what was happening. Of course, we would like to add to the code database as time goes on by interested researchers, provide a mechanism where software tools and algorithms could be shared, since it's fairly clear that reinventing the wheel is not productive. One way to do that is develop common libraries and interfaces between the codes, and to be able, importantly, this will allow us to compare results from different approaches. In this slide, I'm essentially trying to give you a very brief idea of what the gateway framework looks like using the Apache Airvata middleware. Basically, on the left you have the science gateways themselves. On the right you have the computational resources, the supercomputers. In our case, these are being provided by the NSF Exceed program. And in the middle is the Apache Airvata middleware, which manages security, the APIs, handles the data, handles the input, handles the output, the downloading of files, the saving of files, and all the other things that are necessary to carry out the calculations. Using a web browser, you can go to AMOSGateway.org, where you will see the front web page for the gateway. There's a couple of things you can do. You can create a free account, or you can go to the home, where you will find a lot more information about the details of the gateway. Going to the home page, on the left side you will see some nice images that have been collected, which represent various calculations that have been done with the codes on the gateway. On the extreme right, you can see a list of the featured codes, which I'll go into a little bit more detail in a minute. We have the gateway publications, the workshops that have been conducted, and various other topics of interest to AMOS researchers. On this slide in the upper panel, you can see a list of all the various codes that are now available on the gateway. And in the if you click on one of them, let's say on the B-spline R matrix code, you bring up a code overview, which has links to other places where you can find documentation and examples and more details about each code. We have a page which we call Resources, in which we've collected presentations of various members of the groups that have been involved in developing the gateway. We've collected all of these and put them in one place so that users, and especially, let's say, students, can get a good picture of the kinds of things that are going on in AMOS science. This slide shows an example of actually doing the calculation. In this case, it's a CCC calculation. Calculations are called experiments for historical reasons. Basically, you can go to the file storage, you can select an older input file, you can modify that input file to suit your own needs to do a new calculation, or you can create an input file from scratch. Once that's created, you can drop the file in the appropriate place, and it will go into the compute queue and be executed, and the results will be returned to you on the web portal. On this slide, I show some details of the current codes being deployed in the gateway. We have atomic structure codes, which have been contributed by Charlotte Fisher. We have electron scattering and photoionization codes, such as the B-spline R matrix code developed by Zatsarini and Barshot, and the convergent close coupling code developed by Bray and the Curtin group for electron collisions and photoionization with atoms. We have electron scattering codes for molecules, such as the UK molecular R matrix code. And then we have a number of codes which are available to calculate the interaction of atoms and molecules with time-dependent fields, such as T-Rex, developed by Armin Skrinzi, XChem, developed by Fernando Martin, the time-dependent R matrix calculations, and finally we have the ePolyscat code developed by Bob Lucchese at Lawrence Berkeley Lab. In the next few slides, I'm going to show you a little bit about the gateway itself. This slide shows an integrated authentication way to get into the gateway, where a user can log in either by creating a user ID directly on the gateway, or by using things such as common federated institutional logins, ORCID, all sorts of other approaches. This slide shows the deployment of the convergent close coupling code using graphical processing units on expansive SDSC. This is a recent development of the Curtin group, where they've taken their initially their code, which ran on CPUs, and then ported it to GPUs. GPUs are, for those who don't know, are essentially accelerators, which can greatly enhance the efficiency of many calculations. They're the wave of the future, and I think eventually everyone will be almost forced to modify their codes to work on these sorts of processes. This slide shows what happens when you deploy XChem on the gateway, showing the input and output. On the right, you see a number of images which have been calculated and are put out directly on the gateway interface for users to look at. In the past year, we've devoted considerable effort to improving the application interfaces for T-Rex and eventually all the other applications on the gateway. We've started with T-Rex. This slide shows a new view of what a user would see if eventually when they go to the gateway. In the next slide, we see a little bit more about the advanced application interfaces for T-Rex. And in the right side, you see some of the graphical output that one gets. This slide shows the new, if you like, advanced graphical user interface for T-Rex. As you can see from this slide, it's a much more transparent way to input and see output from the T-Rex application, and it will greatly improve the ability of novice users, students, etc., to be able to use these codes effectively. In this final slide, I'm showing some of the statistics of the gateway, experiments that have been conducted, those that are completed, those that failed. I just want to conclude by saying right now there are somewhere between 250 and 300 registered users on the gateway. We get requests almost on a daily basis for new users to be added to the gateway, and we hope that we will be able to keep this project going in the future. I want to thank you very much for coming to the talk and hearing what I have to say. If you have any questions, don't hesitate to contact me. Thank you very much.